Welcome to the Octopus Game. I'm the Backman, who operates and oversees all matters here. In this video, I will share with you how I created the ERC20 Octopus Game token for the experiment. As introduced, every step of the Octopus Game will be recorded and shared for experiment and fun purposes. Would you like to play the game with me? Alright, let's get started with the ERC20 token. First of all, I need a smart contract with the ERC20 standard. Instead of writing the code from scratch, it actually makes more sense to copy and further edit from a credible and secured source or template. There's an open source tool named OpenZeppelin, which contains quite a number of templates that everyone can use. So I will head to the product and then contracts. This is where you can find the ERC20 token smart contract. And now we just added some details here to cater for our Octopus Game token. In my case, the name of our token would be Octopus Game, and the symbol would be OCTG. And the next supply, it would be 45.6 billion. In terms of features, I'll just leave it blank, as I'm just creating a simple ERC20 token. And I'll check ownable. The reason behind is that I'm also referencing the great Pepe Coin's smart contract in addition to this OpenZeppelin template, which I will further explain in details. And then we can move on to Open in Remix, which is an online IDE and integrated development environment. Just wait a bit and decline. I'll just skip all those tutorials here. So now I can see a simple smart contract already. What's next? As I just mentioned, I would also take reference from the great Pepe Coin smart contract in order to add some protective features to our experiment. So let's find the official smart contract of the Pepe Coin. Here's the Pepe Coin's official website, and it points to the Etherscan page. In order to look for the code of the smart contract, I will head to the contract tab. The tick mark actually represents the contract is verified so everyone can review it. Moving to the bottom part, we can view the customized code of the Pepe Coin. On the row 594, we see Ownable and ERC20, which is exactly the same as what I did on OpenZeppelin. And I will copy the whole part from Pepe to my Octopus Game smart contract. From row 631 to row 595 and paste it on Remix. I'll share one of the features based on my limited understanding, so please feel free to advise me on that too. There is a paste the code alert, and I'll just click OK. We can start editing the code. To begin with the constructor, which contains the code that will run during deployment, we'll first edit a bit of basic details. The name, symbol, and supply, nothing special here. While Pepe Coin plugs the total supply, I hard-code the exact number of tokens. The decimal defines the number of digits to the right of the decimal point, and the default is 18 here. And I'll delete the first part, as you can see. Now I'll change the name. Let's undo it. And then copy it. And then delete it again. Below are some variables. I'll move all this to the upper part because the whole scope is utilized by the smart contract. I'll keep some functions and variables including the blacklist, maximum holding, and minimum holding. There's also a burn function in the original Pepe smart contract. but I didn't copy it as I don't think I'll use it. With that, I will try to compile and see if it works. And yes, it can be compiled, so the smart contract can run properly. Before deploying the contract, I will share a bit more about variables and functions. They are actually added for the experiment's protection purpose, especially at the very beginning state of the game, but they will be dropped as I will renounce the contract as soon as possible. So, the most important part is this block. Before every transfer of the token takes place, a check will be carried out. There are 3 requirements in total. If any of the conditions fails, the trade would be rejected. The first one is blacklist. If a wallet is in the blacklist, it cannot trade the token, no matter as a from address or a to address. The second one is Uniswap pair variable, which stores my Uniswap B2 address and is default to 0. So I need to update this later on when the game's on. On top of that, it requires that either the sender or the receiver should be the owner of the contract before the trading is started. It means that no third party can trade the token before I activate this function. Here comes the last variable, limited. It's kind of a switch that turns on or off the following feature. When set as limited, the smart contract will check whether the sender address is from a Uniswap pair address, and if it's yes, the number of tokens held by the receiver address should fall within the range of the maximum holding amount and minimum holding amount being set. If the receiver address holding does not fulfill this requirement, a forbidden message will be shown and the trade cannot be carried out. In Pepe Coin's case, the original owner actually activated the blacklist feature only once to blacklist a buyer who bought around 0.5% of Pepe supply at the very beginning in an effort to prevent whales. The limited feature is also activated once to limit the maximum holding amount, but soon after that, the owner switched off the 2 features and renounced the contract. So I do see these variables or functions as protective measures for my experimental game, but only at the very beginning stage. To add on those Boolean variables, they are all default to kind of empty states. For example, the limited is set as false. Both the maximum and minimum holding amount are 0, and the Uniswap pair address is a null address, and the blacklist mapping is empty as well. So that's it for all the variables and functions. Let's try again to compile to ensure the code can run properly. Yes, there should be no problem, and we are ready to deploy the smart contract. Just a quick note here, being able to compile means that there's no programmatic errors, but the logics in code could still go wrong. So just like me, it might be better to copy and edit from some credible open sources. So let's deploy the contract. We can head to the left menu bar and customize our deployment. There are a number of settings, including the environment that we are using, which account we are using to deploy the contract, and so on. To start with the environment, we can see a number of VM selections. VM stands for virtual machine, but the mainnet will not be able to gain access to the contract, so they are more like a sandbox environment. In my case, I will use the MetaMask, which will inject into the mainnet, and pick my MetaMask account, and the MetaMask should pop up, and we'll just confirm it. After the confirmation, I can see the wallet address, and the next is the gas limit. It's a default amount, and we probably don't need to edit it. As for the contract, I will pick the Octopus Game contract, and that's all. We can proceed with the deployment finally. Let's click the deploy button, and the window pops up. We can check the details, including the from address and the gas, and I will have to sign the transaction via MetaMask, and we can see the creation of Octopus Game pending at the bottom. So here's the MetaMask pop-up, The gas fee is around $50, which is quite a cheap level. After signing the transaction, we just wait a bit. Then we should see the confirmation on Etherscan afterwards. Awesome, it's done. It took less than 2 minutes for the transaction. So we have the ERC20 Octopus Game token, OCTG, live on the Ethereum blockchain. After deploying the contract, I will double check some details. If you record at the very beginning, there is pre-mint parameter on OpenZeppelin when we created the smart contract, and the amount is 45.6 billion. It means that the smart contract will transfer exactly 45.6 billion OCTG tokens to my wallet upon deployment. And yes, we can see that happened on the Etherscan transaction page. The ERC20 token transferred from the null address to my wallet. We can also click into the contract address. We can see the total supply, 45.6 billion OCTG tokens. And there's only one holder right now, which is me, and only one transfer. So everything looks good. But that's not the end. The next step is to verify my contract, as what we saw on Pepe Coin's Etherscan page, the blue tick next to the contract tab. I will upload the code so that firstly people can check whether the code aligns with what I stated on the website, and secondly people can also execute the code on the Etherscan page. If we click the contract tab on Etherscan, some bytecode are shown and it suggests me to go through the verification process. If we click into that, there is a wizard which brings me to several more steps. However, as I'm using Remix for the contract creation, there's actually a plugin that I can use to verify the contract directly on Remix, which seems to be more convenient to me. Going back to the Remix IDE, we can click the plugin manager and search verify. And you can see Etherscan contract verification. Just click activate. After that, it requires me to add the API key, which I can get it on Etherscan. Let's sign into Etherscan and head to API key. Just click add and name my project Octopus Game. And here you go, I get the API key, so I can copy it back to Remix. After pasting the API key, a few things are needed. The first one is a network, and it should be pre-filled and it's loading, so we handle the rest first. Contract name is Octopus Game. As for constructor argument, it should be empty in my case, as you can see from line 14 of the code. And then contract address, just copy it from Etherscan. And that's it. Finally, I can click verify. And it's done. Now we can head back to Etherscan. Refresh it. Awesome. We can see the tick next to the contract tab. So you guys can view my contract now and also read the variables. In my case, the most important part is likely the limited, maximum holding, minimum holding, as well as Uniswap address. If we click into limited, it should be default to false. Both the maximum and minimum holding should be 0 here, and the Uniswap address should be 0 as well. As for the red contract, I will share with you guys in the next video in which I create a liquidity pool for the OCTG token and enable the trading. So that's it for this video. That's how I created the ERC20 Octopus Game OCTG token. Would you like to play the game with me? Please subscribe my channel and stay tuned. Join the Octopus Game if you haven't, and share the experiment with your friends. Thanks guys, see you in the next video.